what is good code? By this point, you should be able to talk a little bit, especially about scalable, right? I mean, readable, we're going to talk about in the next section, but scalable, we understood was big O, right? Well, here's the thing. Don't hate me, but I may have slightly lied or simplified things, but by not that much, so don't worry. We're going to build on that. When I say scalable, there's actually two things that we want to consider as engineers. One is speed. That's what we've been talking about up until now. How fast is our runtime on the code? How much time does it take for a function to run? How many operations does it cost? Well, there's another aspect when it comes to machines. Two valuable resources. One is the time and speed of our code, and the other one is memory. You see, computers have limited memory. Back in the day when computers were just being born, memory was very, very expensive. We only had a little bit of it. And as time has gone on, we have more and more memory, but it's not infinite. Our computers run based on speed, which is usually dictated by the CPU, and memory, based on how much memory, such as RAM and random access memory, the computer has. And those are two valuable resources. So how can we talk about memory? We've talked about speed. What about memory? And the good news is that memory is fairly simple, not as complicated as speed, and it won't take as long to learn as much as we have about speed. Right now, which code is best can be answered with the 3 pillars of code, something that I want you to take with you for the rest of your career, and something that's going to grow you as an engineer, because from now on, when you write code, you're going to have these 3 things in mind. One is you're going to write readable, clean code that others can read, that is maintainable. The other one is speed. The type of code that we call time complexity has a big O time complexity that is efficient. It scales well. But we're going to talk quickly about this third pillar, and that is memory. What's the memory usage of code? If it uses a lot of memory, that's not good. We might have limited memory on our machine. With this one, we use big O once again to talk about space complexity. The same notation, but different topic. One is space, the other one is time. One is speed, the other one is memory. I'm going to give you a quick little preview. Most programming code solution, there's usually a trade-off between speed and memory. You want things to go faster? Well, then you might have to sacrifice more memory. You want less memory? Well, then you might have to sacrifice with increased speed. Let's get into the nitty-gritty of how we measure space complexity.